this is lesson 5.4, and it is about comparing and ordering real numbers. We're going to approximate our rational and also irrational numbers in order to compare them and then put them in order of size. So, as an example, we could try to order the following numbers: 18 upon 5, pi, and root 11. As you can see there's three different kinds of number: a fraction, a symbol, and a radical. Remember, this means, this sign here is the square root. Another name for that is the radical. Okay, so if we had decimals, it would be easier to order them. So the first thing we need to do is try to convert each one into a decimal. Let's start with 18 upon 5. We'll do some long division here, and if you do 18, how many times 5 goes into 18? Then 5 goes into 18 3 times. 3 times 5 will give you 15. We can do a subtraction here. That will give us 3, and we'll have to bring in a decimal, so we'll bring it in on top as well. And we'll carry down our 0. So now we will continue here. How many times does 5 go into 30? That's exactly 3 times. So 18 upon 5 is exactly 3.6. That's our answer for that one there. Let's keep going with the pi. Now, I hope that you remember that pi, the way to write that is pi, is approximately 3.14. That's all you need to remember. Okay? And now we need root 11. Okay? Using from last lesson, if we draw ourselves a number line, we know that the root of 9 is 3, and after 3 comes the number 4, which would be the root of 16, and the root of 11 would fit somewhere in between there, probably closer, as you can see, to the 9 than the 16. So root 11 is in here somewhere, but where exactly? We're going to have to find out. Okay, so far we've got 3.6, let's put these in, 3.6, and we've got 3.14, and now we've got to get an approximate to this here in order to decide how these numbers are going to be ordered. Let's remember how to do that. So we can look at a number and think, well, would it be maybe 3.2 times 3.2? Could that be it? Let's have a go. The way to do that is to multiply 32 by 32, ignoring the decimals. Go ahead and multiply that, and you'll get 2 times 2 is 4, and 2 times 3 is 6, and then put a smiley face. 3 times 2 is 6, and 3 times 3 is 9. Add those together, and you're going to get yourself 1,224. But remember, we were testing 3.2 times 3.2. So if we put our decimal there, we did 1 decimal place, 2 decimal places, so we move that there. Okay, this is too small. We wanted the root of 11. We wanted the number 11. And this is 10.24, so this is too small. So if I just write this in here, 3.2, the root of 11 is actually bigger than that. But where exactly? It's definitely smaller than 4. So let's keep going. Let's try 3.3 maybe, times 3.3. Let's have a look. Now, there's 2 ways you can do this. You can either go ahead and multiply 33 by 33. And if you do that same way, you'll get 99, and then you get 990, and you get 10.89. And so if I put the decimal in there, exactly the same method. So again, it's too small. So let's try one more number. Let's try 3.4 times 3.4, and that would be or you can do that as a, let's do that as a complete decimal, 30 as a complete number there. And same method, you'd get 136 here. Try it yourself. Practice to become fast at it. When you add your smiley face, you'll get 1,020, and when you add that up, you'll get 1,156. Again, we're looking at a decimal here. So let's put that decimal back in, and in that case, we will have moved 1 decimal, 2 decimals, so jump across 2 decimals, and now we've got 11.56. So this is too big. So I know that the square root of 11 lies somewhere between 3.3 and 3.4. Okay? Because 3.3 is too small, and 3.4 is too big. So it's somewhere in here, 3.3 and 3.4. And now I can start to order my numbers. I've got 18 upon 5, which I found to be 3.6. I've got pi, which we approximate to 3.14. And I've got the square root of 11, which is about, we can also approximate that to be well, it's definitely less than 3.4. So I'll put 3.4 there. And now if I need to order this, as the question asked us to do, order them. Now, the order, the way they ask you to order, we're going to put the symbols in for less than or greater than, like that. Going to use the symbols that they've given us. And so now we can say that pi, which is 3.14, is less than root 11, which is less than 3.6. So we've got pi being the smallest, which is 3.14. After that, that's the smallest one. After that, root 11, which was 3.4. And then the final one is 18 upon 5, which was 3.6. You need to go back and write it in terms of the symbols that they gave you in the question. Okay? And so we need this line in the end to write. And in there we would put the symbols in that order. And so next we want to graph these. So I'll just put in this number here. This is about 3.4. And now I can use those numbers and I can graph them here as 3.6. And again, write down the way they showed you in the question. 3.4, it's somewhere between 3.4 and 3.3 and 3.4, so I can put root 11 there. I'll just put a cross in there somewhere. And then 3.14 is going to be somewhere here. And that's where all your crosses should be. And now you have ordered them from the smallest to the greatest. Okay, so we're going to use this method of doing the calculations, the long multiplication, and then adding in the decimal and finding our number to see if we can approximate our numbers here. Have a go at check, pause the video and see if you can do the same thing for these numbers here. What would you put inside of there? Would you put less than, greater than, or equal to? Okay, so if you've had a go at that, then let's have a look. Did you get the same answer? Root 25 over 2 is bigger than root 6.25. Now you can do this on a calculator, but it's actually recommended that you do this manually. So if you're still a little bit unsure, let's take a bit of time to find out. Well, the root of 25 upon 2 is the same as 5 upon 2. Square root of 25 is 5, which would be 2.5 exactly. Now we need to find the square root of 6.25. Well, I know it lies somewhere between the square root of 4, which is 2, and the square root of 3, which is 9. It lies in there somewhere, but where exactly? Let's check the absolute mid value, because then if it falls below it, then I'll know how to order it, and if it falls above it, I'll know exactly which is the bigger number and which is the smaller number between 2.5 and the answer to the square root of 6.25. So how do I do that? I'm going to choose 2.5. I'm going to choose to see what is 2.5 times 2.5. So I'm going to do 25 times 25, and I'm going to work that out. What do I get? 5 times 5 is 25, and 5 times 2 is 10, plus 2 is 12. Smiley face. 2 times 5 is 10. I'm going to get rid of that. Carry 1. 2 times 2 is 4, plus 1 is 5. And I get exactly 625. Now again, put those decimal places back in, 2 places. That means that 2.5 times 2.5 gives me the square root of 6, gives me 6.25, exactly, which means the square root of 6.25 is exactly 2.5. Now let us compare, let me just rewrite this, let us compare what we have here. We had the square root of 25 over 2, which was exactly 2.5, and I needed to know, is it bigger than, less than, or equal to the square root of 6.25? Well, I found that the square root of 6.25 was exactly 2.5. How did I do that? I chose the exact midpoint to see whether this answer would be bigger or less, to know approximately where the root of 6.25 lies. And I found it to be exactly equal. And so I will use the equal sign there. They both equal to 2.5 as a decimal. Okay, you have a go at part B and choose the graph that would represent this. Pause the video and have a go. Okay, so which one did you choose? So remember, we have to change each one to decimal format, to decimal. When we change it to a decimal, we can do a direct comparison. Well, this was 2.5. This was also 2.5. And so they're both 2.5. Your graph should have been graph B.